So I made a big deal that I said always label the left side variable and then the right hand side constant. Now let's say you had this. Let's say you didn't do that, but you solved the equation and you happen to have the variable on the right hand side. Okay. This is the reason why I don't like it on this side. Let's start graphing it. Because remember, you have to solve, then graph, and then interval notation. Let's graph this. So you would have drawn a number line, no big deal. You might have started with 0, no big deal. Number it, going to the positive direction. Remember, positive infinity. Going out to the negative land, negative infinity. You would know that you would put a marker at 2. So put a marker at 2. We know because this is underlined, we're going to use one of these parentheses, like an open circle. Okay? So non-underlined parentheses. Now a lot of you are staring at this and going like, oh, it's a greater than symbol. I know, I'm going to shade greater to the positive. Looks like an arrowhead, it says pointing towards this way. I hate to say this. It's not. You're actually going to go to the less than symbol. You might be saying, no, it's a greater than symbol. I know, you gotta go greater, positive. Why are you going less than? And that's because this is not on the correct side. Think about it like this. When you're doing graphing, by graphing anything, you're showing what the possible answers are, okay? You're trying to tell me all the x's that would make this a true statement. So if I plugged in x is 4 because you thought I should do greater, ask yourself this, is 2 greater than a 4? No. Remember back in Math 055? Alligator will always eat the bigger meal. 2 chickens versus 4 chickens? Yeah, the alligator needs to be facing this way. This is not a true statement. This is false. So you can see why I can't shade in the positive direction. Let's plug in 0. Is 2 greater than 0? Well, yeah, alligator's going to be happy. 2 chickens is better than no chickens. This is true. So you might be saying, well, wait, but it's greater than. Doesn't make sense that it actually all the numbers are less than. It's because the variable is on the wrong side. Now, how can I rewrite this so that the variable is on the left side and not the right side? Remember, alligator. This is a happy alligator. Happy alligator says, no matter what you put in front of me, I want to eat the 2. I don't want this skinny x. I want the 2. So let's play switcheroo with the alligator. Let's take this x, put it over here. Let's put the 2 over here. Now, what do you think the alligator's going to do? Filet mignon or water? If he's hungry, he's going to chase this number no matter what. So he's going to just follow it by opening his mouth to 2. He wants the filet mignon. He doesn't want just water. So when you move the x over, this guy will always follow the one that it's already chosen. So it decided to eat the 2. If I move the 2 over here, it's still going to eat it. Now by having the variable here on the left, this makes sense. X less than 2. See, less than symbol, negative. This is important why you want to have the variable on that left side. Unless you can think backwards and say, well, the x, when it's on the right hand side, I have to actually think backwards. Greater means less than. Most people can't do that. Use the rule. Make sure that the variable is always on the left side to graph. If it's ever caught by accident on the right hand side, you can switch it. Just make sure the alligator is eating the same meal it originally wanted. Right? That's why it's very important to have the left side labeled var, because it makes it easier for us to graph. Because no one would have thought that 2 greater than x is really shading less than until you move the variable to the left.